Just here to stand beside him. But anyway, I'll say a little bit about why we selected a topic like this in an iOS conference. Um, I wanted to definitely speak about something in this conference, and I thought either I'll go first or either I'll go at the end. And the topic that I initially selected was related to caching, how you can improve your caching, in your iOS apps. I was thinking that maybe that could be the first talk, but it wasn't. And Ben's talk was actually the right talk for the first topic for the conference. And then, as Vishnu mentioned, Swift is open source now, and people are using Swift for a lot of interesting things. People have started using it for web development, although not for production yet, but people are starting to look into how they can use Swift for different things. And that's where this idea really came in, like, can we use Swift for Internet of Things? The biggest advantage I see here is now you just need to hire a Swift developer and basically make him or her do anything you like, whether it's iOS app or backend development or IoT or whatever it is. But basically that's the idea. And while working on this small prototype that you see here, we encountered a lot of problems because, as you know, IoT is not easy, and Swift with IoT is very new. And so we discovered a lot of solutions. We found out some issues, then we found a workaround around that. So this talk is literally about that, how you can run Swift on Raspberry Pi, and what are the issues that you might encounter if you want to run it on a Raspberry Pi, and how to basically overcome those. So I'll pass it to Kingming. He will walk through first part of the talk, then I'll come back and share some of the things that I learned.
Okay, so I will begin with a quick demo. Okay, so not everybody can see the setup over here. So I've set up a webcam here, and I stream it to my laptop here. Okay. Then I currently have a Swift program running on the Raspberry Pi. You can see here, it displays the temperature and humidity data. Okay? Okay, so now I have a button here. So when I press the button, yeah, the light turns on here. Okay? When I press it again, turns off. Turn on, turn off. Okay? So what about the temperature sensor? Okay? So I have a hair dryer here. So when I aim it at the temperature sensor, you see the temperature increases. 28. Okay. So I turn it off now. Okay. Okay, so the temperature should drop back down. So this talk is about how did we manage to actually do this. Okay. So this okay. For those who are not aware of what exactly is a Raspberry Pi, so I'll just do a quick intro. So a Raspberry Pi is actually a credit card sized computer. It runs on Linux, obviously not on Mac. Oh, sorry. Okay, so the default Linux distribution is called Raspbian. It comes with a quad-core ARM CPU. It's not x86 like our Macs. 1 gig of RAM, Ethernet, Wi-Fi, Bluetooth. But the real interesting thing is actually the 40 pins you can see at the top. So these are called digital general purpose input-output pins. So with these pins, the Raspberry Pi can interact with the outside world. Okay, so what about the major components? So obviously we have a Raspberry Pi here. Then it has a push button input. Okay? So when you push a button, the Raspberry Pi is able to receive the input. It has a red LED. It has a relay. So this relay is responsible for controlling the lamp you saw just now. Okay, so why do we need a relay? A relay is actually a device, right, that lets you control a large circuit from a small circuit. The mains power is 230 volts. So obviously the Raspberry Pi cannot output that amount of power. So the Raspberry Pi will send a signal to the relay, and the relay will then control the mains power to send power to the lamp. Then I also have over here a Tinsy 3.2. So just think of this as an Arduino, okay? Because it's a variant of Arduino. There's also a DHT32 temperature and humidity sensor. So this sensor will send data to the Arduino over here. Then this Arduino will send data to the Raspberry Pi via a USB serial adapter. Okay, so I'm sure not everybody is aware of what exactly is a serial port. So if you are in the older generation, right, you probably recognize this to be a serial port. Okay, so the serial port, there's another name for it. It's called a Universal Asynchronous Receiver and Transmitter, or UART for short. This is a legacy communication interface before USB. So in the past, right, when you want to use the serial port, you need to specify all these parameters. But today, we no longer use this. But microcontrollers like the Arduino still use the serial port. You can see there are 3 serial ports here. So they are the transmit and the receive pins. And they use this protocol over here. Okay, so how do you actually set up Swift on the Raspberry Pi? Okay, the first thing is actually to use this particular distribution, Ubuntu 16.04, not Raspbian. Raspbian is the default distribution for the Raspberry Pi, but yeah, Swift does not support that. Okay, so where do you get this from? Just go to this site over here, and just download the images for it. Okay, then after that, you fully update the system. This is standard procedure. So how do you get Swift onto the Raspberry Pi? There are actually 2 methods. The first method is actually to use pre-built binaries. Okay. You can follow the instructions in this link, which is what I did. But basically what you have to do, right, is actually to go to here and download the latest build of Swift. This is because since Swift is so new, it's not possible to do things like apt-get install Swift. This will not work because the Linux repository does not have it. The second option is to compile your own. If you're up for it, right, this is possible. But this will take up to 6 hours to compile the Raspberry Pi. Yeah, but this is an option. Okay, so what's the features of our Swift program? So the first feature is that it can get the temperature and humidity data from the USB serial port here. It has a button to receive, it can receive data from the button. It can also receive instructions from the network. For output-wise, we can output to the LED, it can control a relay, and it also can send data out to the network. Okay. So I've used 2 libraries. The first library is called Swifty GPIO. So it's here. Okay, so with this library, your Swift program can use the 40 digital GPIO pins. The second library that I use is actually self-written by me. So it's actually this one here, the Swift Linux serial. This is because, right, I could not find any library that can interact with the serial port for Swift. So I had to write my own. So probably I'm the first in the world to write this, I'm not sure. But I have encountered 2 issues in this. Okay. So this is actually the code that I've written to control the serial port from Swift. So it's quite simple, just initialize the serial port with a name, open the port, and specify all the parameters you saw, the parity, the data bits, and so on. Okay, so in C, right, to do it right, you have to create a structure, initialize a structure. So this is the equivalent in Swift. Okay, so once we get the structure, we have to populate the structure with all the values, all the integer values, and all these are the bit manipulation here to set all the parameters. The interesting part is actually in this section here. So C_cc is actually a fixed array inside the struct. But in Swift, they interpret this as a tuple. So in C, right, you see this code here. This is in C. But in Swift, I have to hardcode the position, .6. This is because I cannot specify vmin inside. Swift does not allow that. So this is not exactly a very clean way of doing, but there's no choice. Then there's another section here. So this function here is responsible for reading data from the serial port. So read here, this is actually a C function. And it requires a pointer to a char array, which is here. So in Swift, the equivalent is unsafe mutable pointer here. Okay, so how do you actually create this? So I have it here. In C, what you will do is that you will do something like malloc the number of bytes here. So in Swift, this is the equivalent here. You need to allocate. So like in C, right, if you want to malloc, you must make sure to pair with the free. So in Swift, you have to deallocate this because you are going outside of the boundaries of the automatic reference counting. So you have to make sure to deallocate it properly with the defer here. Okay, this is another problem that I face, which is concurrency. So concurrency is something like multi-threading. In iOS, if you want to do concurrency, you use something called Grand Central Dispatch or GCD. But the problem is GCD, right? Okay, it relies on libdispatch. Libdispatch supported on Linux, but the Swift package manager does not support this libdispatch, which means you cannot use GCD on Linux. So how do you exactly go and do multi-threading? Okay, okay, let me show you my code. Okay, so I have a function here. Okay, Swift microcontroller, this class is responsible for reading data from the serial port. I have a function here to poll the serial port. But since this is an I/O function, it is blocking. So we should actually run this function on another thread to prevent it from freezing your entire program. Okay, so in the typical way will be to do something like that. Dispatch async the particular function. But since we don't have GCD, we cannot do this. So the alternative is actually to use the Linux P thread, which is short for POSIX threads. The function to create a thread is actually here. Okay, so I've put the function definition here for P threads. So it requires a thread ID, the function to run in the background, and an observer. Okay, so observer is an object that's observing this P thread here. Okay, so how do you do it? So first, right, I have to convert the current Swift pointer to a C pointer here. So you can see this entire bunch of functions to do it. After that, pass observer to the P thread create. Then you pass it in here, and now after that, I have to convert the C pointer back to Swift here. Then after that, then I can call the poll serial function. Yeah. So currently, this seems to be the only way to do it until Apple corrects this problem. Okay. So issues encountered. Okay. So I mentioned that C fixed arrays are imported as tuples in Swift, so you need to hardcode the index. No choice. Swift package manager cannot support GCD, so you can't do GCD multi-threading. Another issue I face is that the GPL may fail to work after repeated restarting of the program. So, for example, during development, right, when you compile, you run your code. After that, you finish, you Control-C to end it. Then you run it again. If you do this like 10, 20 times, right, sometimes the LED will fail to work already. So I do not know, is this a Ubuntu issue, a Swift problem, or a library problem? Just, yeah, no choice. So you just restart the whole Raspberry Pi. There are also some libraries that are based on the older Swift 2.2, so just be alert if you are importing it in a Swift 3 environment. Another issue is that code must be compiled and run on the Raspberry Pi. You cannot do it on the Mac. So if you were to just do it normally, you'll probably open a text editor, because obviously there's no Xcode on the Raspberry Pi. So you have to use things like VI or Nano to do the code, do the work. So, but what I do is that I use an app called FileZilla here. So what FileZilla does is that actually it opens an SFTP connection to the Raspberry Pi. Then I can just edit the file like that. Okay, so I can just edit here. So in this case, although I use Xcode, right, Xcode treats it like any other text file. There's no proper auto-completion here. So after, let's say I modify something, for example, like that, then minimize. Okay, doesn't. Oh yeah, I forgot to save. Never mind. Okay, yeah, okay. So I just press yes, and it will be uploaded back. Then I run Swift build, and the program is compiled. Then, yeah, coding Swift without usual Xcode support. So there's no intuitive auto-completion. So right now, actually, I'm coding with the old way. Every single function that I want to use, right, I have to go and check the Apple documentation for it. I don't have Xcode to help me, which is like very troublesome way of doing. Okay, so now I pass the time back to Sup. We'll talk more about the software portion.
Thanks, Kangming. So as you can see that Kangming has done a lot of good work in this project. So we collaborated on this project, but probably not the best way. So he wrote it first, he ran it first in Raspberry Pi, everything is working. Then he came back to me and showed me the code. And his background is basically from C, and you can see even in his library he wrote Swift like C, which is like not the right way to do it. So when I looked, so my talk is more about how, I didn't touch his library because I just wanted to focus on the code that is running on Raspberry Pi, the core piece, and how I modified some of the things. And although some of the things might be really basic, but you can see the problems that people might encounter when they come from a different programming language to C, to Swift, and then it's just going to give them a different direction to think. So first thing is the code structure. Now, I also looked into a lot of open source web framework. And if you see, they literally have two files. Like a lot of the libraries, they have like a main file and a handler file. In this case, Kangmeng also did the same thing. He has a main file and he had a GPIO handler file. So the main file had about 50 line of code, which was like the entry point to this Swift program. And the GPI handler had over 200 line of code. And a bunch of logic was actually in the GPI handler, logic related to how to interact with the serial port and how to interact with the GPIO pin. All those logic was there. So the first thing we did is we tried to keep them logically separate. In this case, I just moved them into 3 separate files. But the important thing is the main doesn't know much about the GPIO pins. So the main only initializes the Swift microcontroller, which we just put in between. And the Swift microcontroller, it initializes the GPIO pin manager, and the GPIO pin manager is actually interacting with the LEDs and the buttons. So one of the things that he showed in the demo is like turning on and off the LED buttons, like the red and the yellow LED. So you have the red LED and the yellow LED, and yellow LED is basically the relay. And you have for both on and off, state. And this is a way to write in Swift, but it's basically if you want to try to do the same thing in relay, it's basically you check the status and then you assign a value. But that's not a Swift. That's not how you write a Swift program. If you look into this code, right, there are a lot of problem here. The thing is, basically, you do not code like this in Swift. The first thing is this, which is obvious that that you don't put parentheses in if statement in Swift. Then you are assigning some values to the LED. And then we have a Boolean value as well here. Let's see how we can refactor this. The first thing is obviously we take out the parentheses in the if condition. The second thing is if we have like 1 and 0, that doesn't really give me a good understanding of what's happening. Maybe for this particular use case, you can see that it's very simple, but I just converted it to Boolean value so that it's more verbose. The thing that is that, like, if you look into this code, look into it for a while, what is it doing? It is taking a Boolean value, you are checking a condition on the Boolean value, and you're assigning the same value to the status of the LED. So, have you ever written a code like this? Which is basically, if you look into the second line, well, you might feel like a genius, but this whole line can be reduced to this, right? But is it better? If you think, you can do the same thing for relay, but you can do better in Swift. The thing is that if you just use Boolean value and if you use if-else, you'll have the problem of nested if-else when the conditions grow or when the logic grows. So that is why we started with enum. We have a GPIO state, enum, which is going to work both for the LED and the relay. And you can literally put more conditions there depending on if you need more states for different pins. The beauty of enum is that you can use a switch with the enum values, and it gives you code more readability. It clearly tells you that what you are doing with your pins and with the LEDs. But you can also do something like this, like when you're writing switch statement, that is where the power of Swift comes in, that you can really write expressive statements in Swift, and you can make sure that you keep your code simple and logical, and the conditions become more clear. The second thing I'm going to talk about is the safety feature. Now, the library, the Swift GPI library, if you look into this code for a while, so the first line what it does is it returns a dictionary, and the value in dictionary are by default optional, and the way to get the value from the optional is basically you force unwrap the values. Now, the exclamation mark is, I consider as the single most dangerous character in Swift, because if you don't know what you're doing, this is going to crash your program. And in fact, when I was at PayPal, in the code review, what we used to do is we just used to do command F and we used to search for this, and everywhere somebody has used this character explicitly, I was like, okay, you need to get rid of that and use if-let or guard-let. So the same piece of code can be written using guard-let, and which will give you an option to exit early, and return a nil value if your value is not present. But the main thing is that your program is not going to crash. But if you see, I have certain values here which I need to assign, and if I return early, then here I have a nil initializer, which essentially means that if any of this value fails, then my object is going to be nil, which means that whichever class is calling this or initializing this object will get a nil value, and that class also needs to handle that particular nil value itself. The third thing is we use protocols in this, literally three files. But the idea was to make it more Swifty. So this was the initial state, like you have the on button press, and initially this was part of the main program. You press the button and then it changes some status, and then it does something. But it was really a lot of logic for the main function to handle, the main class to handle. So we created a protocol, which is like GPI pin manager delegate, and we are in this case just using for the button. So it will trigger an event whenever the button is pressed, and you basically handle whatever you want to do when the button is pressed. But essentially, this protocol is implemented in the GPI pin manager, which is handling all the pins and button, and your the microcontroller code is basically implementing this protocol. Another thing we did is for the delegate itself, I'm using lazyvar here. Those of you who are not familiar with lazyvar, is basically going to create this object only when it is needed. So the benefit of it is that your object will not be created by default, and you'll save memory, which is really, really essential for embedded devices like where the memory is really less, and then you create objects only when you need it. But this is an iOS conference, so we should have an iOS app to do or control this thing. So that's where we wrote an iOS app. The idea was to, okay, now we need to turn those LEDs on and off through the app using Swift, so which was essentially, it goes back to the talk that Boone gave earlier. But this is how the structure of the code looks like now. We have an API handler in place. The app talks to the API handler, and the API handler communicates with the Swift microcontroller. So there are really three popular wave framework available: Perfect, Kitura, and Vapor. I probably haven't explored as much as some of you have explored the Swift server-side frameworks. But I tried with the first one, Perfect, because it was really the first one that came in. I faced some issues while running it on Raspberry Pi. So there was some issues with the types, and I could have fixed it in the code, but then I thought, hey, let me try something that works out of box. Then I tried the second one, Kitura, and it worked perfectly fine. So let me show you a quick demo. So literally here I have just a button and the status. So if I press, the light goes on. If I now this is so much fun that I can just keep on doing it for the rest of my talk. But let's see what else we can do, because the thing is that I can click on the button and I can make the LEDs turn on or off, but how do I get temperature data? Or how do I get an event if the button on the Raspberry Pi is manually being pressed? How can I get the status of that? So there are a few ways to do it. One is you also can write a REST API and you basically poll for the status and you run it in an infinite loop if you want. But I'm not sure how many of you attended Mugun's talk, but that's going to create a lot of memory issues and performance issues. The second thing you can do is you can send a push notification. You can send a silent notification if you want, and then have the app do something and update the status when that happens. But for IoT, there's a better way of doing things. There's this thing called MQTT, which is really like useful for Internet of Things. Facebook Messenger uses MQTT for some of the stuff. The idea is instead of request and response, MQTT is based on events. So when something happens, so it's basically you have a broker in the middle and you have publishers who publish different messages for topics, and you have subscriber, you can have multiple subscribers. They subscribe to a topic and they receive a message when the event happens. So it literally have like these 5 methods: connect, disconnect, subscribe, unsubscribe, and publish. Connect is you just connect with the MQTT server, and then basically you subscribe for a topic, and the publisher publishes a message, and then the client receives the message when the event happens. So before I go to my question section, let me show you a demo for that. So first I have the same thing, but I have a graph now. The thing is when I can do the same thing here, but I'm just moving off from here. Can you press the button there? And it updates the status on the app as well when somebody manually presses the button on the Raspberry Pi. But I can also get the temperature data. And if you use the blower, you can basically see a spike in the temperature, and it's instantaneous. It's basically getting the thing that is happening instantly. So what did I use for this? First of all, for MQTT on the Raspberry Pi side, you can just follow this link. We can share this links later on. But we use this thing called Mosquito. You need to install Mosquito on Raspberry Pi. And I use this library, Coco MQTT. It works with Swift. But basically, you need to connect with a host and port. You can specify a username and password. For this case, I didn't. And then it has a bunch of delegate methods. One of the thing is like did connect. You can do something. The most important thing is did receive message, which basically gets triggered every time there is a message for the channel or the topic that you subscribed. And this is the link for Kitura, which is really like easy to install on Raspberry Pi. You just need to add the Swift package and do Swift build. It's going to install Kitura for you, and this is how you can just write a simple REST request on Kitura. So that's all for our talk, but we'll be open for questions, both Kengmeng and me. But while we are taking questions, we have this app on the phone loaded. You can just try it out, or pass it around, and you can just turn it on and off from your seats. Let's see whether live demo really works or not. Any questions? So it works.
So I have a small query. So why do you think that Swift did not compile for Raspbian? Because the architecture is the same. Is it because, like, do you know why exactly? Sorry.
Sorry. Sorry. Oh, okay. Okay, so both of them are based on Debian. So in theory, right, it should work. But the thing is, Ubuntu, the packages that come with Ubuntu is slightly different from that of Raspbian. And then when the Apple people, right, they decide to support Linux, they supported Ubuntu on the desktop first for x86. So they depend on some particular version on the Debian packages. Yeah, so Raspbian does not have yet those packages.
Any more questions?
Benji?
Okay.
So after you wrote this wrapper for all the hardware in Swift, and it ended up looking a lot like C, if you would do this again, would it maybe make more sense to actually build a C library with an interface and then bridge that interface to Swift versus writing the actual...
Are you talking about the Swift Linux library that you wrote, or the code?
Mostly writing the code that communicates with the ports and reads data. Like, would it make sense to just build a Swift wrapper around a C API instead of implementing
I think
everything?
that could be one way to do it. But the whole idea about this talk was to kind of show that you can do the entire thing in Swift, including the code that you run on Swift, on Raspberry Pi, to interact with the pins and the MQTT thing. But again, if you see, like, it might be fairly new now, but as Swift gets more and more powerful and then it evolves, we'll have a lot of Swift developers, and basically this gives them an opportunity to think beyond iOS and think into other things like server-side programming or programming for sensors and IoT devices. So I think the talk was to kind of showcase that. But in principle, yes, we can write a C library completely and call it from Swift, which is what I did for the MQTT part, where because the MQTT is actually is a daemon, and when I'm publishing something from Raspberry Pi, I just use the system command to publish the message. Although on iOS side, I'm just using the Cocoa MQTT library to get the data, but on Raspberry Pi is using the system command. So,
Thank you.
Any more questions? Okay.
Nice talk. Actually, I was wondering, how do you see the future of this? Because right now there are many fields, in which you can actually use IoT for smart cities, for smart homes, etc. How exactly you see, where you can use Swift with IoT?
yeah, I mean, as I mentioned, it is not really in production quality at this moment, but if you see, look into 2 years from now, things will definitely improve a lot. And that was the whole point of this talk, to showcase that there is definitely a future of Swift programming in other domains. And the idea again is you just learn one language and you become proficient in one language, you know everything about the language, and then you can do server-side programming, you can do iOS programming, you can do IoT programming just by learning one language. So, yeah.
Any more questions? Okay.
I know that you intentionally chose Swift in this mini project, but have you done a comparison between Swift and Rust for such projects?
So it's quite interesting that Conrad wanted to talk about Rust in this conference, and then Rust is pretty new and awesome, but then again you think about both Swift is new and then Rust is new, and we really need to encourage people to pick one language and become proficient with it first. And personally, to answer this question first, no, I haven't done any comparison with Rust. In fact, I haven't used Rust myself, but I have heard really good things about Rust. So I'm not sure. Conrad might be able to answer that in whatever way if he wants.
The only difference in my mind is that Rust makes it really easy to work with a lot of like buffers and stuff, so you don't have to have unsafe mutable pointer code everywhere. But beyond that, it's pretty similar.
Okay, so any last questions? If not, we'll close. Okay, thank you, Sung Min Kim.